So I think I'll share my screen and I'll revisit the presentation I made to the jury back in 2008. It also kind of allowed me to kind of visualize, have I really evolved as a designer in all these last 14, 15 years? So this is this is how it goes. Actually, it's 2007 as the date says on the presentation. Why I chose this was an important thing, and I'll kind of let all those things go by. But the story of the genesis of this problem was an interesting one. Of course, you will have a lot of, you'll do this, you have learned these processes in your academics, like how you do the need identification and how you do brainstorming. And I think some of these processes are things that I would like complain coming from an engineer mindset. Engineers, we are trained to we know the solution the moment the problem is given, right? And most often when we start building that solution, it turns out to be a wrong one. And designers probably take a little more evolved approach to that in terms of let's try this and probably learn something and build on that iterative way. So it took some time to get out of the engineer mindset and get into the designer mindset. But this project was a classic case study to learn and stay true to that philosophy even today for whatever we practice. So hopefully, show you some of the works that you will see the parallel. Often we would complain about professors. This is a hush hush. Hey, yaar, mera मुझे और concepts बनाने को बोल रहे हैं sir. But it's so true. It's so true that you have to keep doing that. You realize it only with age and a little bit of experience that there's no substitute to quantity in ideas and numbers in concepts and prototyping hands-on. Okay. But this problem came to me in a very first-hand way, wherein I saw my cousin, a younger cousin, struggle to put on the regulator on the gas cylinder. And it looked like a fairly straightforward job. And I kind of went and said, hey, I know how to put it. But I myself started struggling. And it kind of said a lot about how the cylinder was for a simple task like putting the regulator on. But as I sat behind as a student of design and observed what happened after that, pushing the cylinder under the kitchen platform, making sure the knob was on, and all the hassle that people were going through, it seemed like a good idea to think of the gas cylinder from a design perspective. And of course, it looked like a very engineered product. So it was in my comfort zone back then to say, hey, there's a little bit of engineering, a lot of design. So it's a great project to do. So like a typical project, I set out understanding the whole users. At IBC, we were told really well that it's not the end user itself. You have to work out the whole life chain, the life journey of the cylinder. Everybody is a user, right from the day it gets manufactured to the day it ends up getting discarded. And so you see that here we have tried to identify all the products who are touching or are influencing the cylinder in some way or the other. And this is like how the journey would be. Like it starts from the manufacturer and it ends up in the scrapyard if you look at the top. So it incorporates everything from its origin to its disposal and everything in between, how it gets transported, how it gets refilled, everything of that. Then we went out and understood why were there different colors. So there was a little bit about how companies identify their cylinders. We went and saw how people were storing cylinders or people would stack them. It's a very brilliant design in minimalism. People have found stackable in design. You could load it into a small cart, take around. So you'll see how people transport, and transportation was like one of the bigger challenges around the cylinder, because not only is it heavy, but it's also slightly, you have to be careful about not getting it damaged in transportation. Like micro cracks, every time the cylinder gets bumped against something, it will generate some stress in the material, and you don't want any accidents because of these stresses building up over a period of time, right? So we spent a lot of time around the transportation issue itself, how people actually carry or do they throw them around or things like that. And people do obnoxious things to cylinders, like unmentionable things from an engineer standpoint. Then the usability aspect, like how are people actually using the cylinder? Where are they storing? What are their small struggles? Like even when you get a sealed cylinder at home, if you do small mechanism, very smartly designed mechanism, but extremely difficult to unlock if you don't know how to do it. Try doing that. Lifting and putting the cylinder on a trolley, small aspects, all of these were studied and documented in this particular part. And home users had stories like, my cylinder, I do not know when it gets over, and always there's a waiting time before the new cylinder comes in. I'm sure a lot of you now have piped gases coming into their houses. So these problems you may or may not have witnessed, but things were a little different, and things are a little different for people who still get filled cylinders at home. Delivery boys. So you talk to them, you understand what are their problems. Like a lot of them are cycles have gone, and EVs and scooters and all of these things have come in where people are carrying these cylinders. But I actually saw a Sunny. Do you know what is a Sunny moped? Like it was this tiny, and somebody was carrying a gas cylinder on the foot, and it actually split in half. So I had seen this in my memory. I had this incident, how people carry and create accidents on scooters. And so the product itself, if you treat it like a person, you ask it, hey, what are you made up of? And you ask, why are you made like this? So you kind of go down to the every single component, you kind of measure out a lot of regulated products. Like a cylinder has a lot of regulation around it. Like you cannot make a cylinder of your women fancy just because you wish. You will have to get it certified from an engineering agency like BIS. And often they are standardized so that different companies should make it, but they should all have a structure, a shape, a form that is standardized. So there is little wiggle room for us to be creative in a regulated product like a cylinder. So it's very important to understand why these regulations exist the way they exist. So your creativity is within a zone of reference. It is not necessarily an impediment to creativity. It is a structure to creativity if you understand the regulations. So here you will see everything was dimensioned out. The materials are specified. Why are they? Try to get into the material aspect. Like even as a designers, understanding material properties is key, because you will know how these materials will standing. You will not be able to influence the design of a product like this. And then you look at things that the product has gone through. You ask it with your eyes, hey, why are you so bruised? Why are you so battered? What happened to you? And the product will tell stories, visual stories that are easily observable, right? Then you ask, hey, why are you kept here? So you see, I'm talking to the product in first person. And this is a technique that I inherited from Professor Chakravarti. You make the product a person and the product will tell you stories. So you will see it's in different positions. It's often like the most hideous looking thing in the kitchen. So you want to hide it. You don't want to showcase it. So why is a product like this not so beautiful in its appearance, in its life? And so you try to solve all these problems and you will get lost. So you have to have a single one-line problem solving thing as your core problem statement. You can't be solving all the problems. You want to solve them, but there is something core that you're trying to solve. And that one-line problem statement we chose for this product was an easy to handle cylinder. So everything else should be a natural byproduct of a cylinder that is so easy to handle, that it's beautiful, it's easy to lift, it's easy to put down, it's easy to open the regulator. All of that thing should fall naturally. The core is an easy to handle cylinder. And so we said, what does it do? It creates a style statement. So it's not hideous in its look. It's a commodity product. It has to have innovation. It has to be a modern kitchen. It has to have a modern kitchen appeal to it. So you write down your objectives. What are you trying to do under your problem statement? And then there are guidelines, the regulations part of it. Like it has to have 15 kgs of gas. You can't say, hey, my cylinder is beautiful, but it can take only 8 kgs of gas because of it. 15 kgs is a must have. And the regulator is a regulated product. So it has to accept the standard regulator. I'm not going to create a new regulator for the cylinder. And we said that the user should know the level of gas inside. And it should be rollable because, I mean, when I visit this, I would change a few things about this now, the way I understand how design briefs are written. But nevertheless, these are pretty much top level, nice to haves, must haves that you're trying to achieve in your cylinder. And I think this is where the maximum learning for me happened in this project. How do you do brainstorming? Because you tend to get in a rut. You start doing ideas and you will see that all ideas are sounding very similar, looking very similar as you go forward with them. And then you want to create new ideas, which may be wild at this moment. So you use techniques like direct analogy. So what if the cylinder was like a Tesla car? What would it do? Then you do fantasy analogy. Like what if the cylinder was made in, what if a cylinder was to be used on Mars? Would it be any different? What if the cylinder was from a Marvel's DC universe? What would it be? And things like that. So you're using fantasy, you're using imagination and saying, I want to design a cylinder for the Mars universe. And probably it will come a little differently to your mind. So it will help you break out from the engineering mindset here. Then you do indirect analogies, and then you do personal analogies. Personal analogies are like, what if the cylinder was a 5-year-old child? What would it do? So you're creating a personification over there. And then you will see that you will have an idea pool. And I'm pretty sure you've done this chunking of ideas and mixing them together and creating new ideas. So these are techniques very, very useful. And early sketches, like how can I roll it? How can I protect the cylinder? If you see the cylinder, it has what's welded, which does not allow it to be rolled in a straight line. So one of the insight was, if I want to roll it, because of this welding in the middle, it creates this, the cylinder will always rotate in a circle. Like it will go around in a circle if you roll it. So these are all ideas to roll it in a straight line. Then we said, what if it was easy to lift? Like I want to embrace the cylinder and lift it. So these are all ideas to kind of lift it in an easy way. So if there was a ridge, you could wrap your arms around it and around that ridge and lift it. But these cylinders were also around manufacturing. These ideas were around how can I use it? So these current cylinders, they are welded. If I were to use spinning is a technology wherein you use sheet metal and you kind of press it on a turning kind of a machine against a wooden pattern. Now, the advantage is you can use much thinner material over here because it does not need welding. Welding will need much thicker material, right? So how do you go thin is by avoiding welding. So if I don't want to use welding, what are the ideas that I can do? Because welding would require 3 mm of plate thickness. These whole set of ideas came around not using welding as a manufacturing technology. Because if you can avoid welding, you can do really smart cylinders. This is again like merging a couple of ideas, creating forms, using spinning as an idea. Then I said 15 kgs was the gas that was required. But what if it's not one cylinder, it's a stack of 3 cylinders, which are easy to handle. Then you could do like an integrated modular approach. What happens if you do that? So there's a bunch of ideas that come around that idea. And then you said, why do cylinders have to be cylindrical? Aren't there any other better form factors that are allowing you to do cylinders with, let's say, stamping or sheet metal formation technologies, non-regular shapes? So we went around and did these. And we said, let's figure out how to do non-regular.
These look like those petrol tanks, the car petrol tanks. It's possible, actually, where wonderful. Such a pleasure to see the options, students, including that handle option which you showed. The handle actually was, why should the handle be always there? It could be, it could be sort of movable. Very nice. Go ahead.
So the current handle is actually not an handle on the current cylinder. It is there to protect the valve on the cylinder. And so you see that there are these depressions here to protect the valves. We said we could protect it by creating depressions rather than creating structures around it. These are all wild ideas. Let's not get into the feasibility of it at this moment because we are trying to be creative. There's a chance to evaluate and say what is feasible, what is not feasible at a later stage when we choose our final concept. And I'm getting closer to that. So you will see, what if we do a spun cylinder and we put a plastic jacket on the outside? And this is where ideas started getting a little more exciting. You can have all the protection that you want from engineering polymers, and engineering polymers is such a fantastic world that you could have an extremely thin cylinder, probably out of stainless steel. Stainless steel does not corrode, looks really nice, can take a lot of abuse. It's an extremely beautiful material, and you can spin it out into a cylinder, and you put on a really nice modern aesthetic jacket of plastic on the top. And this started looking like the ideas were coming they were freezing into a nice solid concept at this stage. And so with that as an idea that there could be a jacket around the cylinder, you start doing new ideas. Like now you're doing ideas around the jacket. The cylinder is kind of sorted because the world knows how to make spun cylinders. It's not a new technology, but you are saying, how can I bring this technology to a product and make it more suitable for the context and the journey that the product is going to have, right? So you will see that, does the jacket need to be full or can it be half? Now, this is a half jacket concept. Like, I don't want to create a full jacket. How will you kind of assemble the jacket around the cylinder? It's not like a carry bag, right? Like you put it in a carry bag kind of a jacket. So these are ideas around that. And then once you kind of see that the ideas are there, now you want to know what kind of shapes do I want to make. So for 15 liters, I think I love this slide now when I look back at this, because there's a diameter and there is a height, and both of them do the volume. And what the cool insight over here was that you can reduce the diameter by you can reduce the height by a small amount, and the diameter can pretty much stay constant. And so we mapped out what diameters and heights in this image that you're seeing. And we said, hey, we can create a really short, stubby cylinder. The diameter doesn't increase that much, so everything works out. But like, imagine you're stacking them up in the truck and taking away. You could probably have one more layer of cylinders in the same truck. So you're going to really work on the logistic cost of it. So I really love this slide. When I see this now, I had totally forgotten about this slide. But this is all engineering put in a very creative format, like changing the diameter, increasing the height. What is the effect on that? And now this is probably a little more hardcore engineering. So you're trying to figure out how much pressure can it take and things like that. And I'll skip this, but this is important. I mean, if you can't do all of this, you need to have an ally, a team member who's really good at this, because beautiful designs will fail with ugly engineering, right? So as much you will learn this with more and more projects, but there's always a need for an expert, and you can't be an expert at everything. So design is very collaborative in that sense for most products, most digital solutions. The faster you can adapt yourself to work in teams with extremely different people, the chances of that product being successful is much higher. And then we said, what are the possible materials? And we looked at aluminum, we looked at polymer composites, we looked at stainless steel, and what are the possible jacket materials. So this was a little exploration on the material side. And has this been done before? This has been done before. And you will see Chakku sir's letterbox in the whole image catalog when we were doing the mood boarding. Stainless steel looks like a nice material. However bad you batter it up, it's just a much pleasing aesthetic to it. How is spinning done? So you look at the process. Can my product be formed by that particular process? You understand it. And then you kind of refine your concept. So now these are 3 lead concepts, which are an amalgamation of all those loose ideas that were floating around. We have merged a few of those ideas together to form this concept. So this is still a cylinder, but it does not have that. So, remember the problem started with somebody struggling to put on the regulator. We said we will take out the cage and give a much cleaner access to the regulator, but it's still protected. And then it's got this trolley concept kind of a thing going around wherein you can drag it. And then this is an irregular shape just because it had its merit of creativity over there. And then this is a jacketed concept. So there are 3 leading concepts with different ideas going around. And then you do a lot of prototyping. So these are all models made. These were all foam or thermocol models. You will see the irregular shape got tested quite a lot. for how it will get carried around a cycle, on a scooter, how will somebody carry it. Because there's this ridge, and you will see this is Amay Surve, a junior from my time, who is trying to carry it and saying that it's hurting my shoulder. There's a ridge that is hurting my shoulder over there. So now you have three concepts, and you can't have, I like this concept, so I'll make it approach. Of course, you know in your heart and there's an intuition, but you want to back it up with a solid, objective rating. So you create a rating scale and you try to rate it, and you say, hey, how much is this concept better than the other? And this is what a very early stage of rating a concept looks like. Of course, now when we rate concepts, our evaluation metrics are much evolved. We are also bringing in business aspects. We are also bringing in life cycle aspects. We are also bringing in sustainability aspects when we rate concepts now. And the rating is much more detailed, like to a component level sometimes. And so we said, this is it. This is what we are going to make. And then we started doing form exploration. This is my form mood board, a lot of red. I'll probably do this very differently if I do now. And these were some early renders of forms, different forms that we did. There's a lot of inspiration. Some things were lifted off that, but the core concept itself from an engineering standpoint is very different. And that is where the originality of this particular concept comes in. But you will see that we are trying to make it cuddly. We are trying to make it sharp. We are trying to keep it as the topmost image is probably trying to be a cylinder that it is today in form, very close to it, but is a modern version of it. And we said, if we make it rounded, cuddly, like a teddy bear, if teddy bear is an inspiration, how would it go? So different form options here. And then you'd start doing the engineering detailing of it. Like, can the jacket be made in a single mold? Should the left and right molds be just mirror images so that they match, so that you can benefit from less tooling and things like that? And then we created this, cage kind of an effect so that you can see the beauty of stainless steel inside. Why should you hide a material that is inherently beautiful? It also reduces the weight of the jacket in some form. And then we said we could put in an RFID chip inside so that we know how many times it has been filled and refilled. So there's a little bit of tech angle coming here. It is at a concept stage, so no more detailing on this. So when gas leaves the cylinder, it actually boils. So it's in liquid form and it boils and goes into gaseous. And this creates a cooling effect in the cylinder. And so we came up with this idea that if we had a temperature sensitive liquid crystal display, when the gas levels hit that level, it's going to change color because of the boiling inside the cylinder. So the moment it turns a different color, you're going to know it's at the empty level, or that's the time to reorder a new cylinder. And the wheels in a cylinder, they look like an afterthought because I love that idea from the beginning. And that's you see me being unfair to the product by bringing in my love for a concept and forcing it into this concept here. But I think the slide says wheels in a cylinder. Should I do it? Should I not do it? I was still in double minds because there was love and there was rationality that I was saying this is probably unnecessary. Wheels will break. And what happens when the wheel breaks? So should I still do it or not do it? Again, a lot of tech spec around it. This is how a branded version could look like. I cringe at the name now. It's probably a bad choice of name. Easy Gas sounds more like some digestive pill that somebody was making rather than a gas cylinder. And then you make really good-looking models. In fact,
Pushkar, this model is still available with us in the studio.
Yes, sir. You shared a photo with me, and that was so cool to see. So these are all made to a scale of 1:4. And when you photograph it, it should look like it's a real product. And so for 1:1 scale comparison, of course, it was a little too tedious to make a 1:1 model. So you do a montage and you put it next to a friend and say, hey, this is how it's going to look next to you. So that's Varun, who is a great animator from my batch, who is posing next to a cylinder for 1:1 scale comparison.
It's really small.
But it still has the same amount of gas. So there's no cheating there. But I think this is the end slide of this particular cylinder story. And I remember, so there's a new angle that things changed from here. I was so glad this presentation back in the day went extremely smooth for me. Not a single question got asked by any jury. Everybody loved it. Satish Gokhale, who is a dear mentor now, was there as an external jury, design
Yeah,
direction.
he was the examiner. Oh my God, I see.
Yeah, and Satish
Student Satish Gokhale runs
offered
this, industrial consultancy house in Pune called Design Directions.
yes,
And
yes.
then he does a lot of projects for the defense and technology-led projects. And he's also becoming an entrepreneur. He starts manufacturing some projects. So it's very, very effective. And one of our students this time, Snehal, went there for internship. And, she just came back with some very good learning.
So Satish immediately offered me an internship after the presentation. And he's like, you should come join me. And I grabbed that. And I'm so glad there was so much more learning there. But I was very proud of this particular project back in the day, and I think when I revisit it today, that feeling stays. Of course, I would do a lot of things very differently now from the whole conceptualization state, but it's probably, I think there's very little things I would change as well. So now with some experience under the belt, when I relook this project, it's hard to poke holes into the whole concept by itself.